Well, I'm not. Immigration's a game too. You know, when you apply to schools in the United States, your main goal is to, this is how the recording starts. Your main goal is to, because I did a recruitment trip to India maybe 6 years ago. Any of you in here ever been to India? You will feel a lot different about the United States and what we have here if you visited India for a week. So I was there for 2 weeks, and at the, the school puts me up in this 5-star hotel over in India, which is only travelers, right? Because there's none of the locals can afford it. So I befriended the, as a fat guy does, I befriended the head chef at this hotel, and he was making me like traditional dishes every morning that wasn't on the buffet and things like that. And he ended up being Christian, so he invited me to go to church with him and his family. This is the largest Christian church in the world. It's in the center of a primarily Muslim city. Okay, India as a whole is mostly Hindu. That's the primary religion, but Hyderabad specifically is mostly Muslim. So that was kind of cool. But so this is the head chef at a 5-star hotel. What would somebody like that, do you think, make here in the United States?
At a 5-star hotel?
Yeah.
Good money.
80, 100,000, a decent living, right? What do you think he made in India? $1,500 a year. A year. After we went to church, he invited me back to his home. I put that in quotes. He didn't have a door. It was a dirt floor. The whole house was smaller than this room. He lived there with his father, his wife, and both of her parents and 2 kids in this one spot.
Here's what I found.
Thank you. Changes your perspective, and they basically lived in what looked like an alley, and they were walking distance from their home church. They took me to like not the church they go to, but like the tourist, like this is where you can go and see 4 zillion Christians worshiping at the same time, and but it changes your perspective on what we have here. So these students, when they're trying to escape that country and that level of poverty, because with computer science you have the ability to make dollars over here in the United States and also Australia and Canada. I mean, those kind of be the target countries. And what they do is the Indian people are very family oriented. They send a lot of money back home. One of the former students that I've actually connected some of our students here with, his name is Shiva. He was a grad student here years ago. He now owns a consulting company here. He bought his parents a house back in India. So, because when they send their money back over, it's substantial money based on, he makes, I don't know, 160,000 a year here. And he's sending money back over there, and, he's just buying whatever they want. So it's, but the reason they come to places like Concordia is when you apply for private Christian schools, the thought process is you have a better chance of getting your F1 student visa approved. I'm not sure that's actually true.
Oh, but in their heads, like, oh, they want a Christian.
It looks better on paper, something like that. But yeah, I mean, it's big business, but it's exciting stuff. And if we pull away the business of higher ed from a mission work perspective, it's pretty cool. There's just headbutting stuff is what it is. All right. So having said all of that, we did the trip around the world, free vacation. We're talking about creating our inhabitants correctly. All right. So we were looking at inhabitant, player, and something else. Right here. All right. Oh, I have some code that won't even work in here right now. So I was talking about last time we were talking about things that are kind of hidden inside of Java, things that it writes for us that we don't really see, right? And I kind of was proving some of these things. They exist. Trust me, they exist. But one of the nice things that we appreciate about Java is it does some of these things for us. And if you remember back to some of the conversations we had last semester about why I chose C++ as kind of our first language, even though it's, I mean, it's still maybe it's even still top of the list for best languages. It's certainly top 3 or 4 for language, not best, but languages that can get a job with. A lot of that is supporting older code. You know, instead of rewriting projects that have been around for 25 years, you're adding to, fixing bugs, whatever it is, to older code bases. But one of the reasons we start with a language like C++, and I probably use some sort of analogy like with a car. You know, all of you who drive today, you're used to a power steering, you know, an automatic transmission for many cars, right? Fuel injection. Even if you don't know what that is, fuel injection means, like when I was younger, when I first started driving, when you got in the car, you had to hit the gas pedal a couple of times to squirt a little fuel into the engine so that when you turn the key, it had something to light on fire. You don't do that now. You get in, and actually half the time we're doing it remotely from your house, right? You just turn your car on. You know, I'm sitting having coffee in the morning at my house, and I open my little Tesla app and tell my car to defrost. I have a button that says defrost. So it's, things have come a long way, but in order for us to appreciate some of these niceties, we have to see where we came from, right? And we're not going all the way back to, when we were carving wheels out of stone or something, but far enough back that like, hey, this has some nice bells and whistles in it that makes life easier for us. And we kind of saw that last semester with all the little asterisks, this and the little arrow thingy. And when do I use the arrow? When do I use a dot? Just things that always are going to be treated the right way could always be treated the right way, but you were burdened as the programmer to make those choices. Make sense? But had we not seen it, and you learned a language like Java as your very first language, it's easy to forget that those things ever existed. It's easy to, like, if I'm not explaining these things that are technically hidden from you, you would learn like, oh, what is that? How does that connect to what's actually happening behind the scenes? Like you learn a language from the perspective of, oh, this just works, right? And that's the difference you get learning programming this way, as opposed to like some of these online things or boot camps and stuff like that, which will teach you a skill that you can go out and use to perform a task, but won't teach you enough of the under the hood stuff for you to complete that last 10% of hard problems. So really most of the stuff we're talking about is for that 10% that will earn you the extra 50 grand a year. That's that. If you're just taking it down to small little numbers, that's the punchline. All right, so the example I had right up here, this was kind of showing something from at the very end of class. You remember I was talking about the history of Apple, where Apple actually died and we all didn't notice. It's Next computers with an Apple logo on it. Really fascinating story, actually. More fascinating, in my opinion, than the Microsoft origin story, where Steve Jobs convinced IBM to license them an operating system they didn't have. Yes. Yeah, goes into the room because back then IBM was the cool kid, right? IBM was big tech back then. They were the Google of today, or pick whatever up and coming company you like. But he walks into this room with all these high ups, and this is like some kid who just dropped out of college, and it's like I'll tell you what, because they had already Apple really probably convinced the world that personal computers were a thing. Steve Wozniak was building these things, and it became like, oh, normal people can have these personal computers. And so I think it was just Gates and Ballmer were in that meeting with the IBM folk. Alan might have been in there too. He's the one who's making space shuttles and stuff now. But in any case, so they're in this room, and Steve Jobs says, or Bill Gates rather says to IBM, it's like, look, you're going to get into personal computers, you're going to need an operating system to run your computers. And you should use our operating system. I'll tell you what, we'll even make it easy for you. You only have to pay us if you sell a computer. Microsoft sort of kind of invented the idea of licensing software. IBM sells a computer, you give Microsoft a kickback for the license for, back then it would have been DOS. At that exact meeting, it was nothing. Famous quote came from IBM, because this is what made Microsoft zillions, right? This meeting. Anybody know what the quote from IBM was when Microsoft pitched that? Because you're a business person, you're just getting into this new area, and you're not sure if it's going to work or not. Kind of sounds decent to you that like, oh, I only have to give you money if we sell something. It's kind of the Groupon model. Maybe you ever use Groupons? You've heard Groupon, nobody uses Groupons anymore. So Groupon's like an app, you know, and there's all sorts of local places. A lot of them might be like, you know, massage places, things like that, or, you know, florists, whatever it is. But they advertise with Groupon. And the way it works is you end up giving Groupon a bigger cut of whatever the deal is, but you only have to pay Groupon when somebody takes advantage of the deal. So from a small business owner's perspective, like, oh, can I afford to market? Well, maybe not. But what if I got a customer and I only had to pay for that customer, only had to pay for the marketing when that customer arrives? It's a good gig, and Groupon takes a bigger cut. So that's the kind of the model that Microsoft, you know, created. Famous quote from IBM: "No problem, real money's in the hardware." And now all of you are sitting out here in a computer science program instead of an engineering program. That's the catalyst. You know, the engineering hardware stuff is a hobby for us, right? It's like, oh, it's kind of cool to solder stuff together, whatever, build prototypes. And that's still a world that still exists. You go work for NVIDIA or work for Intel making processors or whatever. I mean, you're doing that stuff. But a vast, vast, vast majority of computer science today sit right here at the keyboard, writing vaporware, you know, software that you can just delete at a keystroke. So thanks, Microsoft, for all of that. But they didn't have that operating system. They left that meeting with this deal with IBM, and then they had to go find an operating system. I think Microsoft ended up buying the original DOS, disk operating system, for something like $50,000. And by today's standards, it's probably something like $600,000 or something like that. You know, more than 50,000. But has Microsoft made a little more than 600 grand off that OS? We've done all right. We've done all right. No, we're getting sort of off topic, but we're still on topic, I promise you. Any of you ever read a book by an author, Malcolm Gladwell? He has the book I'm referencing here is something called Outliers. Really, really cool book. He has another one called Blink. I highly recommend either of those, but Outliers is the one that's really cool, and they actually talk about the Bill Gates kind of backstory there. So if you look at the world's current richest billionaires, and again, I don't want the focus to be on the money, but let's call these hyper successful people. There's a huge percentage of them that they were all born during a certain time period. A lot of them have tech in their background at some level. Well, they kind of tell the Bill Gates story of how he kind of became the disruptor. That's in entrepreneurial stuff today. We talk about disrupting technologies. It's a buzzword. And part of it was he went to, I think it was a private high school. And there was this kind of a parents association. I think several mothers were from pretty affluent families. And one of them had a connection with, I don't remember the name of the company, but some company that was one of the early companies that actually had a programmable computer that you could sit there and write software on. Before that, you had to use punch cards and stuff like that. Making changes, imagine sitting there doing your homework when you get 4,000 bugs. Imagine having to redo a whole section of your program and taking it back up to run it again, only to find out you still have bugs. You go back, do it again, back and forth, back and forth, back and forth until, you know, your whole month is gone. And that's for a program that's a fraction of the size of what we're dealing with in here. That's what programming used to be like. So this company had one of the first programmable computers where you could type in code, try to run it. If it was an error, backspace, make some changes, run it again, things that we do today, right? Bill Gates and Steve Allen were high school friends. So they were part of, so they would come in and work on this computer for free that this company brought in and said, hey, mess around with this and let us know what it can do. He worked on it, so they got to play with the future when nobody else had access to it because it was outside of everybody else's price range. And that's what set him up. So this book Outliers kind of talks about this idea of kind of right time, right place. And it's kind of fascinating. One example of a thing from there was dealt with hockey. So how many of you are hockey fans? Watch NHL? Okay, so professional hockey. Would it surprise you at all to know that there's a pretty high percentage of professional hockey players from Canada? That's a thing, right? All right, so a lot of professional hockey players are from Canada. Out of those Canadian professional hockey players, 80% of them were born in the first 3 months of the year, January, February, March. Why? Exactly. Have you heard me talk about this? You read the book? Okay. Yeah. Most people, your mind starts going to, well, were the parents celebrating the Stanley Cup or something like that? It has to do with what the cutoff age is for junior hockey. When you're less than 10 years old, the difference in hand-eye coordination between like an 8, a 9, a 10-year-old is pretty drastic when you're that young and you're growing. So if you're one of the older kids in your league, you end up you're probably one of the better players. You're getting more ice time. You make the traveling squad. You're getting better coaching. All these things add up to you now having this artificial advantage just because of when you were born. Just kind of interesting stuff like that. Another interesting one, I'll just do one more and then we'll get rolling. But I mean, this is actually very related to kind of the world we're in today because we're in that hop. Because what's next? 30 years from now, we're going to be looking back and say, remember how we used to sit there at our laptops and code? We're going to probably be dictating to AIs and stuff what to do, almost like the Chat GPT type stuff. There's going to be a whole career, I think, in the next 10 years, probably less than that, next 5 years, of people who have an expertise in telling tools like Chat GPT the right way. Like kind of, how like when you talk to Siri or something, you have to like formulate things in the right way to get it to accomplish what you want. You're going to have people who learn how to talk to an AI to make sure they ask the right stuff to get the response that they're supposed to get. And that's going to be a whole field. So anyways, this other one was, so we're going to take 10, 15-year-olds from the United States, 10, 15-year-olds from China. We're going to give them each a list of, I think it's seven numbers. We're going to give them 30 seconds to memorize those numbers. 100% of the Chinese students can do it. Less than 20% of the American students can. Why? Now think about where your mind's initially going, right? It's like, well, they're just better at math. Something like that. Go ahead. That's actually probably half the truth. It has to do with the efficiency of the Chinese language, specifically when it comes to numbers. The human brain's on about a 2-second loop. All right. And here we'll connect this to where we're going. Unity, we're going to be talking about that game loop and how long we have to perform operations in between. The human brain's on about a 2-second loop. In Chinese, they could say all 7 numbers in less than 2 seconds. So it'll stick in a single packet flying through their brain. In English, they couldn't quite fit all of them. Saying those numbers in English couldn't fit into 2 seconds. So they had to hold the information across multiple loops of their brain, and that's why they weren't able to remember it as well. It's kind of fascinating, just the efficiency of the language. It has nothing to do with, parents were harder on them with math and stuff like that. And, there might be some truth to some of that just from the grades in school or something from different cultures. There's always cultural differences and stuff, but that's just a fascinating thing that was nowhere near where my mind went. So I was originally reading this book. It almost felt like this adventure where, each chapter were like presented this scenario like I'm doing. And you're like, well, why is that? You know, and in the end, it was almost never what I was originally thinking. Yeah.
How big were these?
Oh, I don't know. Yeah. Probably nothing stupid. I'm guessing 2-3 digit numbers max, something like that.
Oh, that's super quick. I looked up the network with Microsoft today. It is $550 billion.
Or the market cap. That's market cap of Microsoft. Yeah, and that's tiny. That probably doesn't even put them in the top 10, or maybe puts them in the top 10. Because we have several companies that are worth over $1 trillion today. You know, and then you got those hidden companies that, you know, don't report their money, but they think that they're worth like more than the moon and stuff. Most of them are oil companies in Saudi Arabia, I think. Yeah, so then for your soccer players out there, that's the thing with the World Cup this year, right? Like, you know, why is the World Cup in Qatar? They bought it. Why does that surprise you? Companies buy stuff all the time. Microsoft has stolen stuff plenty of times and paid some kid off for, you know, here's $1 million, get away from me. It's the way the world works. It's not the way the world should work, but it's the way the world works. Yeah, but that was an after the fact thing, because one of their sponsors was Budweiser. How do you get sponsored by a beer company and then then outlaw alcohol at the events? That's a bait and switch. It's a pretty fascinating kind of docu-series. I think it's on Netflix about FIFA and the kind of the decision making, and because the United States was like the front runner for who was going to get the 2022 World Cup. And I'm sure they were buying it too, right? You know, they were making all these promises. I mean, there aren't good guys in these stories, but yeah, it's really fascinating just thinking about. But really, it kind of turns towards this idea of the amount of money that's coming out of Saudi Arabia. That just seems very, very interesting, because they're funding all sorts of things to take ownership of stuff. I'm an avid golfer, and I watch a lot of golf on TV. So there's a big controversy in golf right now, where historically the best players in the world are on the PGA Tour. Well, now there's this new tour called the Live Tour, which is backed by Saudi money, and you know, the people make these arguments like, oh, it's evil, whatever. They're all bad guys, you know. But yeah, but the point is that they're able to buy these players off the PGA Tour, you know, players that make good livings, because like I think the average player inside of the top 100 in professional golf, which I mean, that's a really, really, really good golfer. There are a lot of good golfers in the world, and to be top 100 on the PGA Tour, it doesn't happen. It's that's not, so don't think of that as like this, oh, well, he's okay. You know, they're making over $1 million a year, you know, as like, you know, number 94 in the world or something like that. Well, so they can go ahead and they can bring those players in at the Live Tour. They'll give them a signing bonus of $5 million, you know, and then give them some more money. The real math problem was this: is the guy who won the very first Live Tour event was this player called Horsel. This guy won the Masters tournament. He was considered to have a successful career on the PGA Tour. You know, proverbial top 15, top 20 player, won majors, all this stuff. In one weekend, his very first win on the Live Tour, he made more than he had made his entire 20-year PGA Tour career. And he was a major winner. You know, he won one of the big events. Just fascinating, our world today. In a sad way, but still fascinating. All right, good. Yeah, that was the rumor. Probably more than that. Yeah, like, well, but see that gets down to what, you know, what's money. You know, they offered Tiger a bunch of money, he wouldn't take it. They offered Rory a bunch of money, he didn't take it. Well, why not? Well, A, these guys don't need that money, and B, they're chasing history, right? You know, what's Tiger going for? Tiger's, well, assuming he walks again, I mean, he's still playing good golf. But now he needs a cart to get around the course. I bet you he wins another major. That's like his whole history story is like, you know, he won the 2008 US Open with a broken leg. He was using his driver as a crutch, and he had to play an extra, 19, 20 holes to win that event the next day. You know, these are guys that they're chasing historical record numbers. They don't need an extra, you know, $900 million is a lot of money, right? And I'm sure it's a pretty good amount of money to Tiger, but when his brand is worth several billion, I'm sure it's not enough to make the actual difference, even though maybe it would have almost doubled his net worth, possibly. But you know, if you already have effectively an unlimited net worth for a single person, and you just double infinity, you know, and he's already lost his money from the divorce, so you know, maybe you won't make that mistake again. Although, yeah, these famous people, they do keep going back. Yeah, but just fascinating stuff. So I highly encourage you to check out that book, Outliers by Malcolm Gladwell. And then the other one is Blink. I'd read that one second. It's also interesting, but less interesting. It's good, but Outliers I thought was really, really excellent. They just have some fascinating stuff in there that help you understand some things. All right, well, now that we've burned most of class, you have to do the rest of this as homework. All right. Well, I don't think it was a waste of time. We talked about some good stuff there. All right. So anyways, rolling back, I like to show you what's actually happening under the hood so you can appreciate it. All right. So in older languages like Objective-C, when we create a class, we were required to advertise that our brand new object that we're inventing here, like Inhabitant, came from NS object. That makes sense? We had to actually declare that, even though that's how it works. We had to write it. Java says you don't have to write it. It's fine. Okay, we'll write it for you. All right. Now, in the slides, I think we talked about super last time. Oh, here was where we were talking about Apple backstory. So here's the super keyword. Last semester, we learned about the this keyword. This is how an instance of an object refers to itself from within itself. Super is how an instance of an object refers to the instance of its parent from within itself. Now, why is there an instance of a parent? If we go back to this picture here, let's forget about these guys down here. Let's just talk about Inhabitant. Now, we've already said that so we invented this, right? Inhabitant. Now, because that's our top level object, we are building it in terms of the generic object type that's in Java. Even though we didn't have to write it, we didn't have to write extends object, it's there. That means when we create an instance of Inhabitant, when I say something like Inhabitant I is equal to new Inhabitant, like that, there's this variable called I, right? And internally here, I is the same thing as this. I is how this instance of Inhabitant refers to itself outside the class. This is how he refers to himself inside the class. All right, that's the purpose of the keyword this. Nailed it. All right, but now at the same time, as the Inhabitant was being created, an extra super secret thing was being created. Super is equal to, I'm going to write it in kind of a way that matches up. It's actually a little bit different than this. New object. So while an Inhabitant was being born right here, the very first thing that happened was we went ahead and gave value to super. And super is an instance of whoever Inhabitant's parent is, which was object. An instance of Inhabitant cannot exist without an instance of object. And then what is Inhabitant? An Inhabitant is an object with some extra stuff piled on. So what we end up having is we have this thing called super that's sitting here. That's the core of who we are, right? All of us are humans. So somewhere, you know, I don't know, spirit or something. I don't know how we want to go about it. But in any case, somewhere inside of each of us is this core thing called humanity, right? But then each of us has uniquenesses that are built on top of that, right? gender, blue eyes, hair color, length of hair, all sorts of stuff, right? That make each of us unique. Okay. So, so we're living things, then we're humans, and then we're, maybe we go with gender or something, and then you go with, you're an individual instance of a human. You're an individual instance of a human, and you have your own things. But under the hood, both of you started off as generic humans, right? And somewhere at the core, you all have the same commonality. Well, this is actually happening in object-oriented programming. When you create your instance of inhabitant inside the constructor, invisibly, a new variable is being created called super. That is the instance of whoever your parent is. Make sense? Now, if we extrapolate this, oh, well, I got chat stuff here. No, I don't. Yes, I do. Invisible ink. All right. I don't know why that made me think about the movie, The Interview. Have you seen that movie? That movie's hilarious. It's definitely not a Christian movie, but that tiger has seeing what, night vision goggles. That movie's so good. All right, so if we build a player P is equal to new player. Inside of here, we're going to get a super that's going to be equal to a new inhabitant that gets built as the very first line of the constructor of player. So in order for player to exist, player is an inhabitant, which is an object. So when player is being born, as part of that, he creates a variable called super, which is an instance of his parent, which is inhabitant. Now, while that instance is being born, he creates a variable called super, which is an instance of his parent. That makes sense? So this is how we kind of run up the hierarchy, okay? We talk about ourselves as this. We talk about our parent as super. We have no way of directly accessing our grandparent, but we can ask our parent to talk to their parent. We could say, hey, Pops, get Grandpa to send me this, send me something, okay? But now what's nice is we also then get kind of a spill through. Let's say that all inhabitants have names. And we kind of saw this last time. Well, that means a player and a monster both automatically get that ability. All human beings have eyes, right? Individuals. So when your humanity was created, you came with eyes. All right. Now, what makes you unique, though, is you have an eye color, you have an eye color, so on and so forth. So maybe the constructor for player would set that variable that they already got, this idea of eye color, and they would set it to a unique value for that particular player. Does that make sense? But they didn't have to redefine the idea of having eyes or the idea of having an eye color. They got that from their parent. All right. That's how inheritance works in object-oriented languages, not just Java, all object-oriented languages. All right. There's this string of things, but it requires at the very top level for us to have the starter object, the object that is very, very generic on which all other objects are built. Make some sense? All right. So now let's go back to what an inhabitant is. I think remember last time we talked about public, private, protected. Remind me, what does private mean? No, whatever. Somebody go ahead. Yeah. Oh, so a private variable can only be accessed inside of the class called inhabitant. And that's the way I said that. I know I said this last time. It's very important. Not just inside of this instance of inhabitant, but so any inhabitant can access any other inhabitant's name variable as long as they have access to that instance. of it. We'll see examples of this. Okay, but private means you only have permission to get at that variable from within inside the class called inhabitant, even if you're in different instances of who own that variable. Okay. Okay, but it means it's only accessible inside of inhabitant. If you try to access it inside of player, it's going to scream at you. Okay. Now, we're going to go ahead and say that an inhabitant is going to take in the name, and we'll say this dot name is equal to name. I mentioned at the end of class last time, even though we're ending class this time, so we've made up 5 minutes. All right. Well, we did some review too, but I said we're going to do this inheritance model correctly. All right. So when we invent this inhabitant, we're going to say all inhabitants have a name, which means that when we construct an inhabitant, we're going to take in the name and we're going to set this instance of inhabitant's name equal to whatever name was passed in. Make sense? All right. But now we've decided to follow this picture and say that players and monsters both come from inhabitants. So we're going to say a player extends inhabitant. And we're going to say a monster extends inhabitant. And we're going to say when we build a player, we build a monster, both of those guys have to have names. So when we build a player, we're going to go ahead and take in the name. Now, I mentioned that the very first thing that happens at the very top of a constructor is it calls its parent's constructor. If you don't write anything here, it will call the no argument. It'll say super open close parentheses, no argument constructor. Now, right now, this would be an error. Why? Because player's parent is inhabitant. An inhabitant does not have a no argument constructor. It has a constructor that takes one parameter. If I chose not to write a constructor in here, a no argument constructor that does nothing is provided for me. Well, it does more than nothing. It creates an instance of its parent, which is object. Okay, but we're becoming better coders now. So we're going to say, look, to build an inhabitant, I need a name. So the constructor for inhabitant takes a string and it goes ahead and sets that variable equal to name. So now for player, we are not going to, well, first of all, if I try to do this, it's not going to let me. Name is a private field inside of inhabitant. I'm trying to access it inside of a class called player. It's going to scream at me. Name is private inside of inhabitant, means it's only accessible inside of inhabitant. I'm inside a player right now. Can't access that guy. That might be a problem that we're going to make a change to here in a few minutes, but for right now, this is an error. But it just so happens we can still build our inhabitant right now. By directly making a call to our parent's constructor, passing it that name. SuperName here is a call to the parent's constructor, which is this guy right here that takes a string as a parameter. And he sets the name. And this is allowed because we are inside of the class inhabitant where this field was defined as private. We're still going to have a problem accessing this variable from inside a player. But for right now, we don't have errors associated with this. Go ahead. It's asking the parent to set the name for him. So because this is private, a player cannot legally say this dot name is equal to name. He does not have access to this. We'll make it so he has access to it soon. We're gonna change it to protect it. But right now, this is illegal. We can't do that. But we don't want a player and a monster to both directly set their name. They both have the same parent. Whether you're a player or whether you're a monster, can't you just say to your parent, hey, here's my name, go ahead and set it for me? Because the constructor for inhabitant already knows how to do that. One of our goals is not to duplicate code. All right, inhabitants know how to set their name through their constructor. So a player will call upon his parent's constructor, passing it the name. A monster will call upon his parent's constructor also passing it the name. So here in main, let's see, I think all those things are good. Here's our player P. Let's just go ahead and run this real quick. Make sure I didn't add any errors into room and exit. Well, whatever. Okay, this will work unless I introduced errors into room or exit last class. So as soon as the Wi-Fi comes back up or after refresh this page, whatever. But in any case, that's the nature of how we want our inheritance to work. Okay, we say we're going to build ourselves in terms of an inhabitant, so we're going to put all the stuff that's common to just inhabitants up here. And then we're going to differentiate ourselves, players versus monsters, down here. Okay, sound good? All right, I will save this and post this code in Slack. Hopefully make a little bit more progress on Friday, but this was still good stuff today. We didn't get crazy off topic. We just deviated a little bit. All right, questions, comments, concerns, bribes? All right, I'll see everybody on Friday. Tech Talk? That's a good question. Emily's supposed to be getting me the dates this week. So as soon as I get them, I'll put them up.